Okay, quick look then at this week's presentation. We're going to talk about decomposition, functions, variable scope and parameter passing. So it's quite a lot to get in. What are the main areas we're going to look at? Well, first of all, we're going to do a quick recap on decomposition and functions, and then we're going to look at solving a particular problem. So let's get going. So one of the ways that people tend to write code who are inexperienced and maybe come across it for the first time is they write their program as one big monolithic block. Basically just start writing and there's no structure or anything, whole sequence of commands, and it becomes rather large and unwieldy. It's very difficult to test and debug and maintain and really figure out what's going on. And if you need to make changes, it's very difficult to go in there and kind of unpick how it works and change it again. So when we talk about good and well-crafted code, it's basically split up into several blocks, and obviously within Python we call these blocks functions. And each function should have a very clear and individual purpose, and that should be reflected in the name and the description, the comments that you put above and below it, and the stuff that we pass into it and what it returns out. And generally if a function is big and you can't figure out what's going in a function, probably need to split it into sub-functions, but more of that later. So how do we go about actually creating these separate blocks? Well, again, a lot of people who are kind of new to coding write the code and then think, I could do with splitting this up into separate blocks, and they take that block and start kind of carving it up into separate functions. And that's not really the way to do it. We don't write it as one big block and then split it up. What we do is we start by thinking about the problem itself, and we think about breaking that up into smaller problems, sub-problems effectively. And that process is called decomposition, and it's applicable to lots of areas, not just programming. It's about how we solve many problems. In computing, having got these sub-problems or functions, we then think about how we write the block of code for each of those sub-problems or functions. When we come to think about the detail of each sub-problem, it might be that complicated. We've actually got to decompose it further and break it into smaller problems. And what you often find is when you do this, some things seem to crop up time and time again. You need to do the same thing several times, and those sub-problems become functions that we might just call many times from within our program. So a particular one might be that at many points in the program we need to give the users a choice to say yes or no. Well, rather than writing that code to give the users a choice many different times, we would just write it once. That would become a function, and we could call that from anywhere within our program. So essentially the whole issue is our whole problem is decomposed into these sub-problems, and we solve the problem by solving each sub-problem and then going on to the next one and on to the next one. And that's really the essence of decomposition. And like I said before, it's applicable to any kind of problem solving technique that we have, not just programming. When we come to look at programming though, the way we actually code it is not quite like it looks in the diagram on the right there. We don't actually write the first subproblem and then we make the code go straight to the second subproblem and then the third subproblem. I've just realised in my graphic there they're all called subproblem 1. They should obviously be 1, 2 and 3. We don't do it that way because in that case you could only go from the first one to the second one to the third one, and you couldn't reuse any of them. What we actually do in programming is we create each of these subproblems individually, and then we use an overarching function called main to call each of these in turn. So it starts to look a little bit more complicated. Now we've got lots of lines here on the diagram, but if you follow it, it's pretty straightforward. To solve our problem, we start our main function, and our main function calls function 1. So we now go and run all the code in function 1, and the way the functions work is when a function ends, it goes back into the point in the program for where the function was called. So it returns back into main at the end of function 1, and the next line tells it to call function 2, and it goes and runs that function. And again at the end of function 2 it goes back into our main and runs function 3. And in this particular case we've got it to run function 2 again. That's fine, it goes and runs function 2, and again it comes back at the end of function 2 to the point it was called. So obviously as we call all of these functions, we keep a record of where we were in the main program so we know where we come back to. Fortunately, all that's taken care for us by the people that wrote Python, so you don't have to hand code how it returns. It just does that for us. Very clever, really. So just to reiterate it, our big monolithic program is split into these separate blocks called functions. In Python, when we create these functions, the syntax we use is def to define a function, and then whatever name we want to call it, and then some possible parameters and a colon, and we'll look at those later. So how do we add that structure to the code? As we've said, just to reiterate it here, we call all of the functions from main. When the function ends, the control goes back to the main function from where it was called, or if it was called from a subfunction, it goes back to that point. And obviously it allows us to reuse the same block of code many different times. And to start the whole program going, we call the main function, and that's the point in our code where everything starts. And if you've been doing some programming and you've looked at stuff that we've created already, you'll see we always call the main function right at the end of our code, because by that time we'll have defined all the functions, because they're all in the first few lines of code. So here's now a bit more of a syntax about what it actually looks like. Here you can see we're calling the main function with the command main open and close parentheses. That runs the code now that's in the main block. Where's the main block? It's a block that's done with the def main command. And in the def main command, we've not got the syntax here correct. We're just looking at kind of the principles. But obviously under def main, it'd be a colon, and all these things would be indented. And they're basically a sequence of calls. So we'd call block 1, code would run off and run all the stuff that's defined in block 1, whatever that function is, and it would come back. What would we do next? We'd go to block 2, we'd run block 2, come back into our main code, then we'd run block 3, come back into our main code, and in this particular case we're running block 2 again, which is fine. And obviously we could be doing that several times. And from block 2 we could have called block 1, or from block 3 we could have called block 2, which could have called block 1. It doesn't matter. If you call a function, you just return to the point where you called it from. As we look at more structured code, functions can quite happily call other functions. So what we're going to do now in the next section is we're going to look at a particular game. If you've seen the video on how not to write code, then this is the same challenge that we had for that. But in the next video we're going to look at how we would actually do it properly by designing our code much more carefully. So look out for the second video.